Okay, so in the 2024 test, we have three sections. Section A, B, and section C and D. You guys haven't done section C yet, so I'm going to leave that out. All right, so just section A, B, and D. Okay, so section A, the instruction says the following block of code pertains to the next 5 questions. Review the block of code and answer the questions that follow. So the first line, what's happening in that first line? So it's list comprehension, 2 dimensions, right? How many rows and columns do we have? 10, 10, right? Then we have some sort of value initialized to 0. So because of its initialized to 0, we already know that we're going to add and reassign to it, right? If the value was 1, then it's probably going to be multiplicative, okay? So then we have a nested for loop. So we have a for loop, for I loop, and a for j loop. Based on our knowledge of how to determine the number of rows and columns, we know that the for I loop looks at the number of rows, the for j loop looks at the number of columns, right? And then we have a plus equals summation. So from that, you should be able to determine that we are going to add the values, all the values in this matrix to y, right? So every value in every single row, every single column is being added to y, right? And then the output is that value of y. So essentially, it's like that add list function that we created, okay? Now, the first question doesn't really require any calculation. It just says indicate the data type of the output. That output refers to y. What's the data type of y? Integer, perfect. What would make it a float? Right, so if I plus j was some sort of a quotient or a multiplication with a float, your data type would have been a float, right? So if that was I divided by j, let's say, and j was never equal to 0, then you would have a float data type, right? Any division, any modulus will always result in a float data type, right? Any arithmetic with a float data type produces a float data type. The only time you won't get a float data type with a float in the expression is when you do integer division. Okay? So that's something you need to know for Friday. Right? Did I give you guys a list of all the possible combinations? I did. I remember doing it on the board. So it's division, multiplication, division with or without a float will give you a float. Integer division will always give you an integer. Any addition or multiplication with a float will give you a float. Okay? Okay, so now question 2. What is the value of y upon termination? Okay, how would you resolve that? We just said y is an integer. So, okay, we just said y is an integer. So therefore, it cannot be a, because a is a string. It cannot be b, because b is a list. It can only be c or d, right? But d is a float, right? So it can either be c or e. Is there an output? Did you guys understand the process of elimination? Right? We already know it's an integer, so it can't be y. I mean a, because a is a string. Cannot be b, because b is a list. Cannot be d, because d is a float, so it's either going to be c or e. Right? So then you need to decide, is there going to be an output or not? There's no output, so you're saying e. Okay? Let us go test that out. Okay, why did we think there was going to be no output? No, okay. Is it because there was no print in front of this? Right, so I remember when I said, when we use Jupyter Notebook, you can either just call the expression without printing it, right? So that means that there is an output. Now, because of the way the question was set up, right, you don't necessarily have to calculate that value, right? Because you can determine the answer with process of elimination. So as I said, can't be A, can't be B, can't be D. Because we know there's an output, it can't be E. So it has to be C. Yeah. Yeah. It's going to be one of those questions, right? So you would have to understand the code, understand how it works, and then generate the output. So for instance, here, right? If I had two integer values, you would have to calculate it. Because you wouldn't know by just looking at it if it is 900 or 450, right? So if that 450 was an integer, you would have had to calculate it. Yeah. So you would not a random table. You create X. Would you be able to create X? So for instance, if let me just switch scenes. So if I were to ask you what X is, then let's just loop through X for row in X. Print. Would you have been able to create that? Right? Because the equation is I plus j for I in range 10 for j in range 10. Right? So I goes from 0 to 9, j goes from 0 to 9. So then just add those values in combination, right, to get this grid. Then the next step is to then add all of these numbers together to get that 900. Are we fine with that? Okay. So then back to questions. Yeah? Want to see the code? Yeah, it's a matrix. It's a 10 by 10. No, it's exactly the same. I've got 9 columns here. I've got 9 columns up top. The numbers are getting bigger. So it's instead of taking one place, it's taking 2 places. Right? So in terms of byte size, it's bigger. But in terms of the address, it's exactly the same. Right? So 10 by 10. You can see it's a 10 by 10 by the less comprehension. I think we need to have a test every week. You guys are more interactive. Okay. So question 3. How many times does I equal j? 10, right? We're all happy with 10. Yeah, it's just the principal diagonal. We're all happy with that. Well, still, if it was a 10 by 10 null matrix, it'll still be the number of times I is equal to j would still be 10. Its address is not values. The? What do you mean always 10? No, it's just for this setup. So if we had a 5 by 5, it would be 5 times, right?
3 by 2 matrix.
3 by 2, okay, so you would have 3 rows, 2 columns, so only twice. Yeah.
And you compute that
By the lower of the 2. Yeah, so you would have an offset principal diagonal.
Okay.
Right, so it would be 0, 0, 1, 1. Right, so that's the only time they would be equal to one another. Right. Are we all happy with 10? Okay. Now, the next one is a bit more difficult. How many times is j twice as large as I? Yeah. Okay.
Let's say it's first.
Remember, I and j are indices, not values. So it's asking you how many times is this I double j? Was that the question? J is twice as large, so where j is equal to 2I, essentially. 5. Are we all happy with 5? Are we all happy with 5? Yeah. Because if the lowest, so the highest value of j is 9. 9. Right? Are we all happy with indexing excluding the upper value? Right? So therefore it is 9. Right? So then what's the, so if I do 9 integer division 2, what value do I get? 9 integer division 2. Are you guys writing on Friday? It's 4. Right? You round down. Yeah, with integer division, it's always round down. That's why when you say negative 17 integer division 2, it is negative what? Negative 9. Okay. So I'm going to type it out here. Yeah, we're writing on Friday. So I said, what was the first one? I said 9 integer division 2 gives me 4, right? And then I said negative 17 integer division 2. What does that give me? It's negative 9. It rounds down, right? Negative 8 is bigger than negative 9. Right? Okay.
Why is that calculation the logic, or why it's twice?
Okay, so we're checking out all possible combinations of j being double I, right? So the highest that j can be is 9, right? So if I divide 9 by 2 or integer division 2, then the max j can be double I, which is 8, right? So then I just check all of the values that I can be between 0 and 4, which is 5, right? So if I double 0, I get 0. If I double 1, I get 2. If I double 2, I get 4. If I double 3, I get 6. If I double 4, I get 8. If I double 5, I get 10, which is beyond the scope of j. Right? So based on that sublist, I know that the maximum amount of times I can double I to get j is 5 times. Right? So you just work out based on what the range of j is going to be. Right? How would you test that in the code? Yeah, I mean, but then, okay, so I'm just halving j, which is the same as doubling.
Modulus 2 equals to 0.
Okay, wait, let me, which question number is this? It's question 3, right? Question 4. Okay. Let me get my notes. Okay, so essentially what we're going to do is we're going to count how many times j is twice as big as I, right? So with that, we need a counter. Keep track of how many times it happens. How do I check that? if I times 2 is equal to j, are we happy with that? Right? So then we just check what the counter is. It should be 5. Right? So that's going to happen when I is 0, when I is 1, when I is 2, when I is 3, and when I is 4. As soon as I goes to 5, it becomes 10, which is beyond the scope of j. Right? Are you guys fine with index looping? You understand the difference between index looping and element-wise looping? Okay. This is index looping when you loop through a range of numbers, right? Element-wise looping is when you extract the element directly from the list, right? So in element-wise looping, you do not have range, right? So you do not create a set of numbers for it to loop through. It just takes the value from X. So this would be row first. Then it'll go to the next one, which is second row. Then it'll go to the next one, third row. Whereas with index looping, I have to index it, right? So this would be an index. Does that make sense? Right? Index looping, you have range. So you create a subset of numerical values for you to loop through so that you can index from a list. Whereas with element-wise looping, you have the element itself extracted from the list. So you don't have to still loop through each element using indexing. Right? So most of the time I'll let you choose whichever looping method you want to use. If you want to have more control, you'll use index looping. If you don't care about control, you'll use element-wise looping. Okay. So far, how much are you guys getting out of this test? Surely you could have all gotten question 1. Question 2. Question 3. Question 4. No. Okay. So we -1 so far. Okay. Now for question 5. What is the value of I and j when y reaches a value of 200 for the first time? Okay. Okay, think of how you would approach this question. What's the best way of doing it?
So, can you explain the question in different terms?
What is the value of I and j when y reaches? So I'm going to loop through the system. Okay, let me switch to. I'm going to loop through this, right? And then I'm going to add the values together. The question is, at what address, if I were to add that value to y, is it going to exceed 200, right? So we have 0 initially, then we have 1, then we have 3, then we have 6, 10, 15, 21, 28, 36, 45, right? We haven't exceeded 200 yet. Next row we go 46, 48, 51, 55, 60, 66, 73, 81, 90, 100. Right, so we're halfway. Then we have 102, 105, 109, 114, 120, 127, 135, etc. until you reach 200. Right? At that point, we want to know what that number was. So let's say it was 8. So then you have to return the address of it. So that is in the which index row?
604, 46.
So that is 0, 1, 2, 3, and then 0, 1, 2, 3, 4, 5, right? So that's just example. So are you fine with doing that? So adding up all those numbers, getting to 200 and something, I think it's 207, and then returning this number. which is the third index, sorry, third index of the rows, and then the sixth index with regards to the columns. How would you code that? Just break, okay? No, that's fine. So if, so you're saying if y is greater than 200, then break. Well, happy with that? Okay. So then what do we want it to return? So I wanted to say it's a I equals what? Something like that, right? Is that the correct answer? Why is it wrong? Right, so from that manual inspection, we saw that we should get it around this point here, right? So that's the fourth row, but third index, seventh column, but sixth index. Why is it giving us the 10th row in the first column? It's still fine. It's breaking, so it's exiting the for loop, and then it's going straight there. I mean, like, you kind of right. Where do you want the, okay, so if you want the print inside of the for loop. Now I'm just going to print it every time J changes. So we're not getting a definitive answer. Yeah?
I think what you're checking here would be different. I think you want to check how many times, how many addresses, rather than the total of the I and J. So then wouldn't you
Yeah, okay, so if you do the total number of iterations, how are you going to determine which one's I, which one's J? So if it does it 40 times, which one is I responsible for, which one is J responsible for?
then that's when you would then do that.
Do this.
No, as in,
I mean, okay, it's fine if
you
you,
have your counter
yeah.
of how many.
Yeah, so
times
let's say
I-
the count is 40. So are you counting how many times I is changing, or J is changing, or both?
You can do both.
So you're going to have 2 counters,
Yes.
or 3 counters.
I wouldn't know whether you need 3 counters. I know
Well, I mean, so you would have to count the overall number of iterations and then check which ones I are responsible for, which one J is responsible for. Okay?
using that.
Okay? Okay, let's go back to what the break does. What does break do?
Takes you out of the loop.
Okay, so it takes me out of this loop.
Yes.
It doesn't take me out of this loop. That's why it breaks here, but I continues. That's why I goes to 9 and J to 0. So what you would need to do is you need to have a break for both of them. Right, so once it breaks out of this, it needs to check again if it is, so then it breaks out of both loops. Oh, well,
So you remember how during COVID, you mean like lectures, like teach certain sections, like do something similar for this one as well?
I'm recording a video right now.
I'm just asking.
Okay, I'm recording a video right now. So this will be available to you afterwards. Were you listening at the beginning?
Yes.
Okay, I'm joking. Yeah, it's just a bit difficult at the moment because I have to do it for 318 and for you guys. That's why I'm trying to incorporate AI into generating the videos, but AI makes a lot of mistakes. So then I have to go back and fix those mistakes and edit those videos, which takes more time than me just recording it. What I will do is during VAC, I will record videos. Because at the moment it's also difficult. Whenever I'm in my office, people just show up without booking consultations. So I can't record in my office either. Okay.
Question 5, how can you do it by example? In a theory paper, there's this theory, right?
Yeah. Yeah, and I'm just showing you how you would prove this with coding. But with the theory paper, you would do this calculation. Are you fine with doing this? Yeah. Yeah, so you would do, I mean, you don't have to do everything. What I would do is, so obviously, when I'm lecturing the course, I'm omniscient, right? So I know exactly where the spot is. Whereas if I was a student, I wouldn't know. But I only have 5 possible choices, right? So then I could map it out to include either all of these or map it out to include the first ones I'll see. Which is the first one you'll see? So if I'm looking through rows and columns, I is for the rows, J is for the columns. C, right? Check C. C is way below 200, so obviously it's not C. Then what's next? A, right? Check A. A is also well below. Then E, right? Then D. Once you get to D, it's done. Right, so at D, you should get 207 or something. Let me just check what. Let me just check. So let's see what the value of Y is. Right, so the value of Y is 207, which means we added the 9 to 198. Right, so it goes from 198 to 207, which means at this point, it then exceeded 200. Okay? Would you be fine with doing that? Like as with last year's test, it's all about shortcuts. Right? Once you can figure out a shortcut, you can solve the question quicker. But when I set up the paper, I test it based on the longest possible way you can get to the answer. So even with question with A1, the question was based on you extracting all of those values, so produce a full 10 by 10 matrix and then calculating the value to equal to 900. So because you already did that in A1, you have it ready for you at A5. Okay? So on Friday, whenever you make rough notes, don't throw your notes away. It might be useful later again. Okay. Number 6. What's the answer? Yeah, it's D. It's all of the above. Right? I can import it as NumPy. I can import it as star, which means I'm going to import everything without saying NP. And then I can just import NumPy and just say NumPy every time instead of NumPy. I said this in lecture 2. Do you guys go over the lectures? Clearly not. Okay, one more trick. If these two values were swapped around, it cannot be E or D. Right? Does that make sense? So if I put E or D, it cannot be one of those two, so it means the answers are A, B, or C. Right? If I do something like that, right, just remember that. I like to do that. If D is all of the above and if E is all of the above and D is none of the above, it cannot be D or E. Right? No, sorry, it can be D. Sorry, my bad. No, sorry, it can be D. Right? So if I have none of the above, then it can be D. But if I have all of the above, then obviously it can't be E. Because E can't be all of the above and none of the above at the same time.
What about of those lecturers that put none of the above at A,
There's nothing above, so then
but then
that's right. Technically, if they put it at A, then technically it's correct.
that's my point.
Yeah, but like I mean, there's something above, none of the above here.
Okay.
Right? Now I'm saying like it can still be none of the above. So if D was none of the above, yes, it can be that. But if all of the above is in E and there's none of above it, it can't be none of the above and all of the above at the same time. Right? Why somebody
Only
do
if proposition.
Yeah. That's what I'm saying. Like if all of the above is in E and none of the above is in D, then obviously E is not an option. Right? Don't go and pick E. Okay, so in question 7, we switch to a new block of code. Can everyone see that? Because you guys don't like to read instructions, right? Here it says the following block of code pertains to the next 5 questions, right? So that is 1, 2, 3, 4, 5. So it's question 7, right? When it says the above block of code, it refers to the code above it immediately. Okay, what's the answer? So the question is, the above block of code uses NumPy to create a NumPy array. Please indicate which of the following explains the dimensions of the array best. D. Everyone happy with D? All wrong. But you have an answer.
So you're saying it's not the above, it's too low, right?
No. That is a depth. So if we just focus on reshape, that is a depth of 2, which means 2 faces, 3 rows, 5 columns, right? So technically D is correct, but it's not. What's 2 times 3 times 5? What's 100 divided by 5? Yeah, so it's none of the above because I'm trying to create or trying to reshape 20 elements into a space of 30. So it's going to give me an error.
If you don't know the answer, you see
Are we all happy with that?
Can you re-explain it, sir?
Okay, so how do I determine the number of elements that's going to be created by NP arrange? Right, so I have 0 to 100, so that's 0 to 95, right? In increments of 5. So all I can say is just say 100 divided by 5, which means I'm going to get 20 elements. Happy with 20 elements? Then I check the dimension of the matrix I'm trying to put that 20 elements into. Size of that is 30. Right, so I have 2 times 3 times 5. Right? If I try and cast 20 elements into a matrix of size of a matrix that can take 30 elements, I'm going to get an error because it's going to be blanks. Right? So therefore, it's none of the above. Okay? It's going to be very technical on Friday. So just watch out. Yeah? How do I? So this would have to be 30. Right? So that would be 150. Right, so here I don't get an error, but if I do it with 100, I get an error. Right, so it says cannot reshape array of size 20 into shape 235. Okay, Okay, now with question 8, it's just going to be about memorizing of lines, right? You haven't done this before, so I don't expect you to know it, but just normally in Python, your methods are majority of time in lowercase, right? The only method that you're going to have that is cap locked in it is data frame, from what I can recall now. Okay, question 9, given the block of code above, the numbers printed will be, so it's basically just describing what the function does and what it's going to output. Is it A, prime numbers, B, the Fibonacci sequence, C, perfect squares, D, even numbers, or none of the above?
Even numbers?
Everybody fine with it being D? I first want answers. Everyone fine with it being D? Everyone fine with it being D? Yeah. Answer is perfect squares. Right, so here we are doing what type of looping? Element-wise looping, right? It will be index looping, so for looping. It is for looping is okay, but like there's two types of for looping. You have your index looping and your element-wise looping, right? So that means you have to extract the num from here, right? So you can do it maybe for the first few numbers. So 0 divided by 0 will give you an error. Sorry, no. So it starts at 1. I'm well happy with it starting at 1, right? So 1 divided by the square root of 1 is 1, right? And then 1 integer division square root of 1 is also 1, right? So then that number gets printed. Then we go into 2. 2 square root of 2 is not the same as 2 square root of 2, right? So then we already know that it's not even numbers, right? So therefore, D is now out of the equation. Fibonacci sequence is also out of the equation. No, not yet. No, it is. Yeah, 1 plus 1 is 2. So Fibonacci sequence is out, even numbers is out, so we're left with prime numbers, perfect square, and none of the above. Then we go on to 3. 3 divided by square root of 3 does not equal 3 into division 3 square root of 3. Then we have 4 true, 5 false, 6 false, 7 false, 8 false, 9 true. So the three numbers are all perfect squares. So by then you could probably just say perfect squares. Okay? If you're not sure, just test out all of the numbers. But normally, if I have square root and integer division together, you should already think of perfect squares, right? For even numbers, your key clue would be modulus, right? Prime numbers will be factors or some sort of factor. And then Fibonacci sequence is just where I'm adding the last two numbers of a list. Okay? I'm going to say that again. For perfect squares, there will always be square root and integer division, right? So square root here, integer division. For your Fibonacci sequence, I'll be adding the last two numbers of the list together, right? So you always see a -1, -2 indexing. Then prime numbers, we will be counting factors, right? So if it has 2 factors, it's a prime number. More than 2 factors, it is not a prime number, right? Even numbers, modulus 2 is your clue. Fibonacci sequence is when we will be adding the last 2 numbers of a list together. So it'll be indexing of -1 plus indexing of -2. Right? If you can't remember that, just run the whole code as you would just manually, and then just check what the pattern is. Are we fine? Verse 9. Okay. Then for 10, what's the answer? D. We'll find with it being even numbers. Right, just note that because there's a not in front here, this changes not equals to equals. Right? Are we fine with that? So because this not is in front of a does not equal, right? It's a double negative. So not equal is equal. Okay? Okay, and then for 11, it is Fibonacci sequence, right? Because I'm adding the second last to the last. Now, what about 12? As Denzel said, when in doubt, pick none of the above. Okay, is it prime numbers, Fibonacci sequence, perfect squares, even numbers, or none of the above? We've already done Fibonacci. Yes, Fibonacci. Oh yeah, and the test, if I use a word that you don't understand, just let me know. I will try and explain it to you, or I'll just explain it on the board, right? So like I said, with Fibonacci, it's just when you add the second last to the last number of a list. Okay, your hint here is line 9.
What is this even numbers?
Even numbers is when you have modulus 2. I have modulus I now. That's why I said modulus 2, not just modulus. Is it A? Everyone happy with A? You're wrong. It's E. So the reason for that is because the upper value of num is exclusive, right? So that means that one factor is being removed from the equation. So essentially every number that's being printed is a number that has 3 factors. What do we call a number with 3 factors?
Like 27.
Yeah. Well, yeah. No, 27 has... No, 27 has more than 3. It's 4, yeah. What do you call a number with 3 factors?
There's 18. That's 4 as well. What about 9? That's 2. Oh, yeah, 1, 3.
You go ask ChatGPT.
What's the equal? Let's give it a name.
You're doing it already. Okay, essentially what they all have in common is that they are the squares of prime numbers.
Squares of prime
Yeah, so 7 squared 49 only has three factors. 1, 49, 7. Right, so that's what this is doing. It's giving you prime squares, not prime numbers.
But then, why is 5 there?
5. There's 5 in this list.
5 is a prime number.
Yeah, but 5 now it'll give you 25. So it'll be 1, 25, and 5. Right? Let me just show you how that works. Right, so I'm going to just do one of these tricks. I'm not going to do a lot of them. Right, so if I run this, I get 4, 9, 25, 49. Right, those are all the squares of prime numbers. To get the prime numbers, I have to include the number itself. Right, so if I'm checking for 5, I need to check 1, 2, 3, 4, and 5. Right, because now it's just checking 1, 2, 3, 4. So the only fact it's finding is 1, so it's not adding it to the list of prime numbers. Right, so now I have 2, 3, 7, 11, 13, blah, 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 all the way to 97. Right, so just read through all the code before you answer the question. Okay? Okay. So question 3, 13, 14, 15 is just talking about various indentations. Okay. Question 13, in the previous question, the increase in the incrementing variable counter in line 8 has multiple indents such that it can be executed if line 7 evaluates a true. Okay, that's true. It lies within the scope of the for loop initiated in line 4, which is also true. It lies in the scope of the for loop initiated in line 6. That is also true. So therefore, it is all of the above. Right? Are we happy with indentations and scope? Okay, perfect. Then number 14, which of the following is true about nested for loops? A loop inside of a function, that's incorrect. A loop that runs infinitely, not necessarily correct. No, can never be correct because it's not a while loop. A loop inside of a loop, so therefore C. And then 15, which of the following is true about elif statements? Technically, there's two. Okay, no. So an elif statement must be used in conjunction with an if statement. That's true. An elif statement must be used in conjunction with an else statement. That is false. An elif statement is executed if the preceding if statement or elif statement is true. That is also false. Yeah. So technically A is correct, but also E is correct. Right? Because an elif statement, if we just look at the previous if statement, can also be an elif statement. Doesn't necessarily have to be an if statement. But in the entire code, there is an if statement. Right? So technically, the elif statement cannot exist without an if statement. Does it make sense? But last year I gave them half a mark if they said this. Right? Not necessarily. So if I'm so this question's a bit vague, right? Or the statement is vague, right? So if I said an elif statement can be used in conjunction with an if or and an elif statement, then that would be correct. And or sorry. With it just being an if statement, because if I have an if, elif, and an elif, then you could say that that elif lives in conjunction with the previous elif statement. But there is an if statement, so actually no. The most correct answer is 15A. Right? I'm well happy with that. An elif statement cannot exist without an if statement. Okay. Ooh. I assume everyone's happy with B. What's the answer for B1? What? Calculator. Oh. Yeah, please bring a calculator on Friday.
What time is it?
It's during the track.
9:35.
Yeah. Are you all happy with writing during the TAT?
Writing.
Yeah. Brian, are you fine?
How much time do you have?
It was just last week that you had an issue. Okay. So that's 9:35 to 11:25. We'll probably stop at like 11 or something. Well, I'll confirm the venue tomorrow. Okay, what's the answer of B1? Okay, what's the maximum the answer can be? What's the maximum value the answer can be? 2, right? Because it's modulus 3 at the end. If it is greater than or equal to 3, then it means 3 can go into it one more time. Right? So if you say modulus 4, it's incorrect. Then the modulus should then be 1. Because I can divide 4 by 3 again to get a remainder of 1. Right? So here your answer is either going to be 0, 1, or 2. Right? Answer is 2. Why is the answer 2? What's 100 modulus 7? 2, right? 2 modulus 3 is 2. Perfect. Now here's the example we did earlier. Negative 28 integer division 3. Negative? Negative 10. Are we all happy with negative 10?
Number 2.
Yeah?
So please can you go back to number one?
I'm saying 9.
What's wrong with number 1? Okay, I'll show you number 1. Hello?
It's 100. Modulus 7.
Did you say 100? What's 100 modulus 7? Are you fine with it being 2? 100 modulus 7. Seven times. So it's 100 divided by 7, which gives me 14 remainder 2. Right? Then I have 2 modulus 3, which equals 0 remainder 2. So therefore the answer is 2. Yeah. Right? Modulus is the remainder. How many times is 3 going to 2? 0. 0 times 3 is 0. 0 times 3 is 0. Hi boy. 0 times 3 is 0. 2 minus 0 is 2. Why would the modulus be below 0?
Like, if even if you can say 2, like, modulus 10,
2 modulus 10 would just be 2. Yeah.
so what I'm saying is, any like, answer you get from modulus, that's just his answer.
I've actually never. Let me try negative modulus. Negative 1 modulus 2. It's 1. Your modulus will always be positive.
Okay.
Right?
So,
You were talking about denominators and numerators, so it would be 1 over 2, right? Which is a half, but you would need to round down, right? So you need to round down to 0. Then we'd say 0 times the quotient or the denominator subtracted from the numerator. Does that make sense? Right, so here it would be your numerator is 100, denominator is 7, right? 7, so 100 divided by 7 gives me that 14. Right, so I say 14 times 7 gives me 98. 100 minus 98 gives me that 2. Right? Just do that the whole time. Okay. Negative 28 integer division 3 is negative 10. Right? We're all happy with that. Right? Negative 28 division 3 would give us what? Negative 9.333333. Round that down to the nearest whole number is negative 10.
Then can you see said that by modulus?
Yeah.
Why, since it's something going to 8, why don't we round off to the
It's performing integer division. Right? That's why integer division was introduced, so that you can do modulus. Right? So, did you guys do, was it in TAT 2 I asked you to do modulus without using modulus? Right? So that was 100, right? Minus 100 integer division 7 times, what do we multiply it by? Times 7, which gives us 2. Right? So this will round it down to 14. 14 times 7 is 98. 100 minus 98 gives us 2. Right? Similarly with that 7, so it was 2 modulus 3. Right? That is just equal to 2 minus 2 integer division 3 times 3 equals 2. Right? Are we happy with modulus? Are we happy with integer division? Okay. Now, before we execute this, what's the data type going to be? Everybody happy with integer? Boolean, right? Because I have a comparison operator. So it's either going to be true or false. Why is it false? So you're saying this side is bigger than this side. Why is that?
Because you want to see 3 to the like the total
Using this line.
27 squared is 81.
3 to the 1. Like 2 plus 7 is 3 to the power 5. This is false because the left-hand side is smaller than the right-hand side.
What's the left hand side?
I think it's 3 to the power, if it's not 5, it's 6. I'm forgetting the rule.
Okay, so with PADMES, you do parentheses, then exponents, right? So we do whatever in the parentheses first. So we cube that 3 to get 27 and then square it, right? When there are no parentheses, we do exponents, right? But with exponents, we go from right to left, right? So we do the rightmost exponent first, right? Then we do the remainder. So that is 3 squared, which is 9. 3 to the power of 9 is whatever it is.
Or you can, because you're multiplying.
But don't we do multiplication if your index is just outside the parentheses? Is it multiplication of
No.
or it's addition?
No. So like this is exponent, right?
Yes.
Right. So why do you want to do multiplication? Are you talking about the exponential laws from normal mathematics? No, don't worry about that yet. Just focus on Python. No. Well, so that's normally when I multiply exponents with the same base, then I just add the exponents, or if I multiply exponents with the same exponent but different bases. Are you talking about that rule?
But there's that rule, but there's also a parenthesis rule.
In exponents.
I think so. I'm not sure. Let me verify my claims. It's fine.
Multiply every. But that only works with
Yeah, but I mean, like this parenthesis is just saying I'm squaring 3 cubed, which is 27. So I'm multiplying 27 by itself.
myself. I'm asking about the second. So it's 3, so power of 3.
Yeah, so in Python, right, it's going to take your exponents from right to left, right? It's going to
So it's gonna say
it's going to do that first. So it's gonna square 3 first.
which is 9,
Yeah, then it's going to put 9 to the power of base 3,
which is 12. No.
which is a big number.
Yeah.
Right, so all we know that this number is smaller than that number, right? So therefore it's false.
Yes, man.
So the law is 8. So 3 to the power 3, right? To the power 3 units, but then it's in brackets.
Okay?
But power 3 is in brackets,
So 3 to the power of 3 in brackets.
right? And then to the power 3.
Oh, so you're saying I can just multiply this and this
Yes.
to get,
In that case, it's true.
so you're saying like that.
Exactly.
Yeah, no, that doesn't work in Python. So it does pitness first. It's going to do this first and then do that. Right? Do you want to see it? We'll see. So it's first going to do what's inside of the brackets, which is 27, and then square it. Right? Remember, in normal arithmetic, we have BODMAS, which is brackets of something. There's no exponential in there, right? So with the natural rules, it doesn't really transcend into this. You can account for that based on where you put your brackets, right? So for that, you would want to say this. Okay. That was weird. Oh, no, sorry, still 27, 27. Oh, sorry, I'm saying what you want to do is this. So you want to do this essentially. Right? So that's where it accounts for it. So if it's not inside of brackets, it's going to account for it that way. Right? So you see, that's why there's a 9 there. Sorry about that. Yeah. Okay. Now for, I think, what question is this? For 4, right? First of all, you need to decide what data type is this going to be. Does it make it bigger? You're supposed to be following on your own PCs. This is going to mess up the recording now. Okay, recording seems fine. Okay. So we have I, the power of I modulus 3 for I in range 10. Okay, first of all, what data type is this going to be? Is it going to be a list or a list of lists? Just a list. So one-dimensional array. Perfect. Okay. Then, how many numbers will there be in this list? 10. Okay. Would you be able to write out those 10 numbers? Okay. Right, so all you're going to do is substitute 0 into this, calculate it, 1, calculate it 2, 3, 4, 5, 6, 7, 8, 9, get the last value.
Also, the ones are for those numbers that are perfectly divisible. There's no remainder.
Yeah, so then it's just to the power of 0, which is why you have these ones. Right, so it's going to be with 1. Yeah, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The thing is, like, if you guys fail, imagine what that's going to look like.
Is it running us the wages again for Friday's test?
The weighting in terms of your overall mark, or it's so it's 60-40 split, so it's 15% in total. So right, test 1 is 15. You want the weight to be
No, I just asking.
different. We can make the practical test way more because it's open book. But okay, let's see what happens. I'll adjust the weighting whereby it makes more people pass. Yeah, no, it's fine. Yeah. Y is 0 to the power of 0. When do you want me to prove it now?
No, I just want to know why.
So if I do this, what do I get? 1, right? That's the same as saying 1 to the power of 1 minus 1, right? Which is 0. I can do that for any number. There's 1, which is the same as 2 to the power of 1 minus 1, which is just 1. Right, so why shouldn't I be able to do that with 0?
But 0 divided by 0 is not 1.
Yeah, but I mean, this is a workaround. Like, there are papers where they say that the division by 0 should be possible. Yeah, so what you do is you use a limit approach. Like, the answer should always be you going to positive infinity or negative infinity. Yeah, you'll never converge to a real number. Yeah? Is she stretching? Yeah?
Why is the second index 4? The second one.
This value. Okay, so that would be what? 3, right? Modulus 3. Sorry, 2, yeah, 2. Yeah, so it's 0, 1, 2, right? So 2 to the power of 2 modulus 3, which is just 2 squared, which is 4. No. 2 modulus 3 is not 2 times 3. It's 2 divided by 3 remains. So then you just check what the remainder is, which is 2. You need to make sure that you know exactly what all those operations do. Do I need to go over modulus again? Okay, so I'm gonna generate a new question. What's the answer? What's the answer of 97 modulus 5? Why is it 2? Right, so that's 97 minus what's 97 integer division 5? 19. What's 19 times 5? Does that make sense? Okay, again, for question 5. Right, what's the data type of the output going to be? Boolean, right? Because we have our comparison operators. What's the answer? Why is it true? Okay, so this is true, right? So we have true and so 5 integer division 3 is true, right? Sorry. 5, okay, 5 integer division is 1. Sorry, I was thinking of modulus. Yeah. And then 5 integer division 3 is 1, right? So it's true. Right? So then we have true and we have false or true, which is true. Then we have true and true, which is true. Right? If I ask you to show your working, that's what I mean. Okay? So remember when we did all those combinations, we said false or true is false. Yeah, true. True or false is true. True or true is true. False or false is false. Right? Then we had true and true is true. True and false is false. False and true is false. False and false is false. Then we had XOR, which is this.
Oh, that's XO.
Yeah. What does this evaluate to? I'm just going to run it. What does it evaluate to true?
XO means that either or is true.
One of them has to be true, one of them has to be false. So, or one of them can be false, right? Not. What do you mean not? Not is just the opposite. So if I say not true, then it is false. XO. So XO means that the conditions on either side of it, one has to be true, the other one has to be false for it to be true. So if it's true, XOR true, it's false. If it is true, XOR false, true. If it's false, XOR true, it's true. If it is false, XOR false, it is false. Right? So it can only be true if one of them is true and one of them is false. One of them has to be true. And both of them have to be true. What is 5 modulus 6? 5. Right? So that is false. Right? Then we have XOR. What is 3 to the power of 2 to the power of a half? Yeah.
It's the power squared of 2.
Okay. So it's false? Is it false? Yes. Is it false?
What is 3 to the power squared of 2?
It's definitely not 3. Yeah, that's true. I'm saying that 3 to the power of the square root of 2 is not equal to 3. That is true. The only way it can be equal to if the square root of 2 is equal to 1, which it's not. Right? So then I have 3 times 2 to the power of 3. What's that?
That's 8, no, 16.
It's 20, so it's false.
So now that comes to my question. XO 1 is to be 2 has to be false. What if there's 3?
Then you do them in pairs from left to right.
So you do false true, and if that's true, then it's true, and then you do true false. That's true. Okay, then it's true.
Yeah. Right, so we have the first section here, false or true. False X or true, so it's true. And we have false, which is true. Like when I show you guys the stuff, did you not envision this happening? What did you think that were they there for fun? Okay, out of section B and section A, which one do you want to weigh more? Section B. Section B. Are you sure?
It's a lot easier to know.
Section B.
Okay, well, let me just go check the mark allocation. It's 20 and 15.
That's fine.
Are you fine with those weightings? Okay, let me quickly do section D and then we can leave.
Section C, you don't want to do it because long as it says,
Yeah, this is pandas. Do you know what pandas is?
yeah.
You know what pandas is? So in 2024, I had a bunch of students that already knew how to code. So yeah, by the time we got to week 3, we had skipped 2 lectures already. They already knew how to code basic Python. They already knew, like from Comp Sci and the stuff that I told them to go look at. Told them to go look at Kaggle and stuff.
Or last year.
Yeah, no, 2024. No, last
I'm
year.
saying you told them in their third year to check those stuff out.
No, I told them at the during orientation. Okay. So section D is similar to question A, it's just that the function is now much bigger and the amount of information you have is quite limited. So it says below is a block of code that contains a function called x. The function calculates the area of or the perimeter of a right angle triangle. The function takes 3 arguments based on the values passed. It will calculate either the area or the perimeter, right? Based on that code, when will it calculate area, when will it calculate perimeter? Okay, quick, my battery has 12 minutes left. Okay, so the hint is line 3, right? Area is a argument for this function. If area is equal to yes, it calculates the area of a triangle, right? The way you would know that is if you know what the formula is for the area of a triangle, which is half base times height, right? If that is not true, it will calculate this, which is just the perimeter, right? So based on these 2 lines of code, what is the answer for line 12?
C.
Now that's going to calculate the area of the triangle. Okay, wait. So it's half. Yeah, half base, which is 4 times height, which is 6. Perfect. Then for line 13. What's the answer going to be? Right? So because it's case sensitive, it's going to calculate perimeter. Right? So that's going to be 3 plus 4 plus 5, which is 12. Right? We're all happy with that? Okay, I'm going to stop the recording there quickly before it gets corrupt.